Možda nije uvek lako pronaći u gužvi informacija, ali oslušni tu je. Na dohvat ruke. Pusti je da te vodi i završit ćeš baš tamo gde želiš. Novi doživljaj mobilnog bankarstva. Banka Intesa. Banka pod vašim prstima. Na dohvat ruke. Pusti je da te
Hello
vodi
everyone.
i završit ćeš baš tamo gde želiš. Novi doživljaj mobilnog bankarstva.
Sorry, we have some technical issues. Now we have a speaker, Karol Przystalski. Karol obtained a PhD degree in computer science. He is a CTO and founder of Codet, where he leads and mentors the teams working with Fortune 500 companies on data science projects. Gives speeches and training in data science with focus on applied machine learning in German, Polish, and English. He used to be an O'Reilly trainer. In his talk, he will show the most common mistakes made by managers, developers, and data scientists while building AI products. He will go through 10 case studies of products that failed and analyze the reason for failure. He will also present how to avoid such a mistake. His title of his talk is Avoid Mistakes Building AI Products. Karol?
Hi, thank you for the introduction, and thank you everyone for joining me today. As Vuk mentioned, I have a PhD degree that I obtained in 2015 at the Yale University in computer science. My background is artificial intelligence. I do machine learning for about 15 years now. So I started doing it before it was cool, and you can find some of my papers on Google Scholar, for example. Most of them are related to machine learning in medicine, so how to apply that. But that's actually from the scientific point of view. I also run a company, about 400 people now, that is, where we actually we apply machine learning models, machine learning methods in commercial products at the end. So first of all, that I would like to tell you is are the buzzwords or the hype. When I started my PhD or started my company, doing any kind of machine learning was kind of so the companies didn't want to actually use machine learning because they told that there was some magic behind it, a lot of math and so on, and it wasn't really so cool at that time. Now it's actually the total opposite. Since I don't know, a few years back, you might heard about terms like AI is the new electricity or AI is the new UI. So it's changed a lot. I mean, on one hand, it's good because there are more applications with using machine learning. On the other hand, machine learning is not the solution for everyone and for every problem, right? So that's something that you also should be aware. And based on some studies, I know the statistics are actually before the COVID came, but I don't think it changed too much. So 40% of AI startups, I mean, the so-called AI startups in Europe, they don't really use AI. I mean, they tell that they use AI, but at the end, they don't. Why they say they use AI? Because they can attract the investors more. I mean, they can get more funding. So probably if you would have a chance to get more funding from 15 up to 50%, then for sure you would tell that you are an AI company, even you don't use AI. And sometimes you can see that actually some basic statistics, I mean, some methods that you can count them as machine learning methods are counted as, the big AI stuff that is behind, like, I don't know, linear regression, for example. And also based on a different research, you can also see that actually 85% of the AI project fails. That's maybe not not a surprise, because in general software projects fails quite often, unfortunately. And here, additionally, the research part comes actually into account. We need to think about the research part. That I mean, machine learning is kind of a research, because you need to build some models, you need to figure out something out from the data, and so on. So it's not typical software development. So there is an additional risk factor that you need to add, and this is why there are so many failures. So what I would like to tell you is actually, first of all, explain a bit what machine learning is for anyone who actually doesn't have a clue, and then actually go deeper on potential failures that you can do, not only from a technical point of view, but also from a business point of view. So what is actually machine learning? So there are easy 5 questions that you can ask to distinguish between different types of machine learning methods. For example, if it's a cancer or not, is it B or A or B? There's a classification problem. So we are classifying some objects into one group. So we can also find anomalies. So if we are looking for something weird, something that doesn't looks like the other objects we have, or as I said, with the linear regression. So regression as a group of methods is about what is the y when the x change. So how many, how much, right? Or how the objects are organized. If we don't have the label, if we don't have information about what actually the objects are, and we can group them to give them actually a label, a group name, a cluster name. And the last type of methods are the reinforcement learning. So if you play a game, for example, a video game, then going through, that's actually reinforcement learning. So learn by doing it and actually get a reward. It's like training a dog, for example, right? So more or less that's how it looks, how it works. When it comes to artificial intelligence, we have 2 types of artificial intelligence. So artificial general intelligence and artificial narrow intelligence. When it comes to ANI, actually all of the methods that we have now are actually ANI, because they are just dedicated for some specific task. So very limited specific, like for example, if we have an algorithm, a model for actually recognizing a cancer, then it will recognize cancer. It will not, I don't know, learn how to drive a car, for example, right? So that's what AGI do actually. It's able to learn more, actually, something that it wasn't really dedicated to train at. I mean, it wasn't designed to be trained for at the beginning, but then it trains more. It's kind of a, something like the hosts in Westworld and so on. And there are not really AGI solutions yet. Probably when we will have more advanced quantum computing, probably it might be possible, but I'm not sure if this is really something that we will be able to solve with machine learning, because machine learning is just one of the ways how you can actually implement artificial intelligence, right? So artificial intelligence, AI, is cool on slides, but actually machine learning is the implementation of AI that we do in Python. I don't know, mostly in Python, sometimes in R, Scala, Java, and so on. So one of the things why the machine learning methods fail, right? Or why we fail using machine learning is that these days, one of the group of methods that are very popular are the deep learning methods, so deep neural networks. As you can see here, here's an example of an inception network, one of the inception networks. You can see each of the blocks is a piece that actually is doing some calculation. So it's a lot of calculation it needs to be done actually to get the final prediction or the final decision. And well, most of the blocks here, the blue, red, yellow, red, and so on, works more or less like a black box. I mean, we can using some methods like GradCam or other explainability methods, try to find out what is each block doing. But it's quite difficult in many cases to figure it out. In some cases, even impossible. So that's why actually it's complex, and it's also hard to figure out what's happening actually obviously we expect if the results are good, then we are fine with that. But at the end, it's some explanation. That's something that we want to have. So buzzwords. You might heard about I don't know, blockchain, for example, in the past. Machine learning became such a buzzword a few years back. That's good. As I said before, it's good that we have more and more applications. But on the other hand, well, again, machine learning should not be the first choice in many cases, right? Because we saw what happens with blockchain, for example. It was cool for 2 years. Then actually, most people figure out, oh, okay, why should I use blockchain instead of a, I don't know, typical, let's say, database, right? SQL-based database. In most cases, the answer was, well, there is no difference. So why should I use a complex solution instead of a simple one? And it's also the case for machine learning. But in this case, still, there are much more. I mean, many more applications compared to blockchain. But it also depends on the term, because artificial intelligence in general is a quite wide term, and there are plenty of other small terms that actually you can as kind of a subset of artificial intelligence. And you have the hype cycle. If the term is actually here on the bottom part of the cycle, or even in the last two parts of the cycle, we can tell, okay, they are major enough. Actually, what is the worst thing you can do is to do something, apply some of the solutions, even if it's not really useful there, when the hype is the highest, so everyone wants to do that. You heard about chatbots probably a few years back. Some journalists wrote that actually chatbots will replace the customer support and so on. And it didn't happen. I mean, it didn't happen in such a scale how it was actually how they asked or how they told that should be. Well, that's really what happens. I mean, the chatbots are not so intelligent still, and there is a lot of work that needs to be done before this technology will be very major. I mean, chatbots at the end are intelligent. It's about the way how we develop it. All right. So common mistakes. So one of the first failure is again, how you should avoid the hype. Again, if it's something on the hype curve, you should not pick the one that actually where the hype is the biggest, because in most cases there is a simpler solution available. And again, if you want to do that, just fail fast. It means if it doesn't work after a POC, just drop it. Right? There is no way. There is no reason to spend much more money on that. Okay, let me tell you a story about a girl, a little girl with a little red cap. And you probably heard this story in your childhood. There was also a grandma and a big bad wolf. And the case here was to deliver a piece of cake and a bottle of wine to the grandma by this little girl. But because of some circumstances, some cases, some issues that happened in the meantime, well, the question was at the end, I mean, in the story, how to distinguish between a grandma and a wolf, right? So, well, it's obvious, and it's an obvious question. I mean, it's an obvious answer. It's for us humans, it's easy to distinguish. But let's imagine you have a case where actually you need to distinguish between wolves and husky dogs. For everyone who doesn't know what a husky dog looks like, this dog looks very similar to a wolf. I mean, in some cases, it's very hard to distinguish. I mean, people who know the dogs and know how it looks a wolf, they will find out the details like the ears, the nose, the size, and so on and so on. Some of the features that are actually you are able to distinguish by between the wolf and the husky dogs. And some researchers did a research in the past. Actually, they obtained around 90% of accuracy, but they figure out, okay, let's check what are the features, the most important features here. And they figure out that actually you see here on the right, there is a gray color. It means, oh, these are not the features that are important. So the nose, the ears, the eyes, that's not important. What is important here was the background, it means that the images that were delivered for building model, they took actually images of husky dogs on the couch, I don't know, in the garden, but the wolf, it was in the forest, on the snow, so in the wild. And this was actually the major feature, which is quite logical, but for us, for humans, it doesn't make any sense at the end to distinguish between these two types of animals. So another failure that is very common is actually the way of companies do machine learning. They are not really AI companies in the meaning that they don't really have the strategy. They have no strategy for data storage. Most of the companies that I meet, that I met, they really have data, but the way how they store it makes it impossible to really run the machine learning right away. So there is a lot of work that needs to be done before actually you can use this data and actually apply machine learning. Another thing is that many companies building something that is cool, not really that is something that is actually adding any value to the company. So it is also important that actually, on one hand, it's good to have a very cool, nice model that solves a very cool problem, but the solution should also give something to the company, not just solving a problem that doesn't make any doesn't add any value to the company. So that's also very important. Use the process, as I said before, the way how you build machine learning or data science project in general is a bit different than compared to a typical software development process. It's because we have the research part that is actually part of of a machine learning based project. So building a POC, it's a good starting point for our machine learning project. And obviously doing due diligence, it's also very, very important. Also using the right data, right? Here you can see Tesla car crashed the truck because the car told that actually the background here was this truck, and the truck was the background. So overfitting, or actually underfitting, is also something that we need to work on by preparing the proper data, test and train data set. The team, I see very often that actually the companies doesn't have the proper team to really solve the solution. That's also quite logical, because machine learning in the past, machine learning engineer was told to be a person with a PhD, with a huge math background, which is not true in these days. And finding now a person who actually does have experience, on one hand on machine learning, second in the domain that the project is done, is quite difficult. So what you can do, you can find obviously someone on the market, or try to do some peers with some external companies who actually specialize in that, and then actually after that try to recruit someone. From the engineering point of view, I also see a very common popular problem or mistake made by the engineers, that they try to reinvent the wheel, and meaning that they try to build a method that is already there in some TensorFlow library extension, for example, or I don't know, or PyTorch. You have it there, but they just try to reinvent the wheel. That's not the right way to do it, because you lose a lot of time, especially if you're on the POC, in the POC phase. Also using the proper hardware, that's also typical mistake. I have here my M1 MacBook, where actually I have also my GPU on it. Where actually most of the many of the cases I do here, but sometimes I use also the Intel extension kit that I can use to actually run to train the model. If something is more complex, I have my RTX on my PC that actually I can run it there, or at the end use a GPU or GPU that is in the cloud. You need to find out the cheapest solution for you, because there are so many options here that probably most of the cases buying an RTX NVIDIA graphic card would be the cheapest solution for you, instead of actually going to the cloud, because that's something that you spend and you have no hardware, right? You spend the time and that's it. And obviously focus on the security. That's a typical problem, and it's growing. I mean, the topic of on security in machine learning is growing now because it became more and more important, especially that we have more and more applications in production. Here you have an example of a Tidewheat bot. It was a bot developed by Microsoft in 2016. It was published, and as you can see, after 24 hours, the bot became a racist. So that's not the way how you should do that, obviously. So from my experience, just to give you a few examples, some time ago, a travel company, a travel agency approached me, and they said, okay, we have tons of emails with some requests for the flights and so on, and want to use our NLP method to get the information out from this email and actually put it in a database so we can easily search for specific data. So what we did, we took some sample data from them and figure out, okay, look, there is no NLP needed here. You can do it with regular expression. That's a cheaper, better solution, more robust in this case. We can do it for you, but it's not NLP, it's not machine learning. They actually decided to do the NLP method because they got a funding from the government for our machine learning solution, which is wrong. I mean, that's not the best way to do to solve problems. In this case, you can see that actually typical regular expression was the solution for that. Another thing is that a bank approached me to help them. They ask us for consulting what they do wrong because they do build the POC, the same POC for the 8th month now. That's an obvious mistake, and the only solution is just stop because you're just doing something bad, something wrong, and well, the POC usually shouldn't take longer than 3 weeks. In some cases, it might take a bit longer, but it's exceptional, and 8 months is just way too long. So it means they probably try to solve a problem that is not there is no solution for that. So a chemical company, they ask us to actually find out and apply some machine learning methods to the data they have to automate getting some formulas out of the data they collected. Well, the problem here was not really machine learning and what kind of methods should be applied here, but the data that they had. Again, they collected data for 5 years. That's great, but the way how they collected made actually the data useless. So the first thing was actually to train them how to do data pre-processing and actually get some information out of the data for machine learning first. Another bank, they had an idea to build a chatbot. So what we did for them, we helped them to build a retrieval base. I mean, they built a rule base, but they didn't have really knowledge to actually build an intelligent one. So between a rule base and a retrieval based chatbot, the difference is that the retrieval one is more intelligent and can get context from the customer instead of just doing a text string passing in what is actually done in rule based chatbot. One of the other cases actually is from a car company. We did a very nice solution for a couple of months and so on. And at the end, we figure out actually this solution will not be used in Germany, but in China. And after 9 months of development, we just throw this project away because of some law regulation in China. It wasn't really possible to use it there. In Germany, it worked fine, but in China, it didn't work. So it was a 9 month of spending project that didn't give us anything. Some of known failures, again, some security failures here. Adversarial attacks, very interesting topic. How to, as you can see here, the man on the left is recognized, the man on the right is not recognized because of the picture on it. We can also have some stickers on the signs to be not recognized by the car. Or, for example, Alexa that suggests to suicide herself for a better good. That's also a mistake, obviously. Or here, Google, that is a bit racist, as you can see here. That's not me that did that. That's Google. Or IBM that actually they applied Watson to suggest prescriptions for people that are they have cancer. At the end, it was worse than actually it was before. So the patients felt less worse after actually applying this kind of recommendations. And here the Uber autonomous car kills the pedestrian, the bicycles. So how to do the AI transformation, right? You should think about the whole process, like assembling the data, pre-processing data. In some cases, also feature extraction and feature selection, because it depends on that what kind of method you use. Then obviously training, prediction at the end, and validation if it works, and obviously retraining if we want to continue and maintain the production-ready application. Because the whole process is not just training phase and the prediction phase, but also retraining that is actually coming after the prediction. Let's say the called maintenance phase. That's how it looks like. So the last thing that I would like to tell you today is how to actually transform your company, how to actually start the project to make it properly. So based on Andrew NG from Coursera, he said that actually there are several steps, like building some POCs, build your team, provide them some training, because the machine learning is the world AI is actually changing all the time. There are new architectures applied. You should actually follow the NIPS articles. So still you are very scientific at the end. And also build a POC, the process, right? Including POCs, for example. Avoid actually tasks like achieving some specific accuracy, because it makes sense to some point, but actually after some point, actually getting a 0.1% increase, it's even impossible. So what is very important actually before you start any kind of AI project is to do a due diligence meeting. Where actually there are two types of people attending this meeting: AI experts and domain experts. So domain experts means the people that actually knows the knowledge in this industry. And just only part of it, the one here marked with orange, is actually the project are able to, that you can do it really. The rest is something that is, you cannot do it with machine learning, or the solution doesn't give any value to the company. So you need to set 5 questions to do during this meeting. Can we do it with machine learning? Do we have enough data? Do we have people to do that? From a technical point of view, and from a business point of view, do we reduce the costs or increase the revenues based on that, having the solution, or do we launch a new product or new service? All right, so summary. First of all, due diligence. Just start it every time before the project starts to figure out if it's really doable. Second, don't use machine learning at any cost, and please fail fast. That's a typical approach when it comes to the startups. Also applies to the machine learning projects. If you want to hear more about what I did in the past, or how to commercialize your scientific ideas, please find some of my TEDx talks, or in general YouTube talks that are available on YouTube. And if you have any questions, feel free to ping me on LinkedIn, or just ask any question here now. Thank you very much, and yeah, that's all from me for now.
Thank you, Karol, on this amazing presentation. Yes, we have one question. Do you have some suggestion or advice for junior developers that want to make an AI product?
Well, if you're a junior developer, it depends on your experience. I mean, what actually you have, what do you have really, what kind of knowledge you have when it comes to software engineering. What I would do in the first place, if you don't have any experience in machine learning, I think Andrew and G courses on Coursera on machine learning are the right place to start with, because you can learn more about what's in the background, what's going on there. Then obviously learn Python and actually start from there. But again, in most cases, you will not face issues with machine learning itself. You will face problems related to data. how to get the data. I did doing my PhD. I spent 1 year to go to every dermatologist in my city to get any kind of data. So I spent 1 year to get the right data. It's a really long time, and the machine learning method wasn't really an issue. And this applies to many other cases.
Thank you. Yes, there are no other questions. Thank you for this, and I hope see you on some of our next events and lively.
Thank you very much. Thank you.
Thank you. Bye.
Bye-bye.
Bye.